Thank you for having me, Joe. So yeah, my name is Nikki. I work for an American-based company. They hired me as a systems administrator, and then they decided that wasn't actually that fashionable of a job title and we should consider changing it up. So now we're all DevOps engineers and DevOps department. And then we have the software engineering department on the other side. So it's a work in progress. We're getting there. I'll give you a little bit of context about Illumina. We build instruments to sequence genetic data. And what that means is that if you've ever sent a blood sample to a hospital to go and look for some kind of genetic variant, some kind of disease risk, you've likely used our hardware's been used to understand that. But also everything from agrigenomics to pharmaceutical industry to all kinds of places over the world can use this technology. And the reason they can is that the cost of sequencing data has dropped by orders of magnitude every 2 or 3 years. So cool technology, cool science, cool progress being made. What do I have to do with that? Nothing at all. I do the informatics things. But the informatics problems have changed. Because if you look at the cost of sequencing one whole human genome there 15 years ago, you're not going to get dozens of those. You're not going to get thousands of those. Nowadays, we have people sequencing tens or hundreds of thousands of genomes and then going, what do I do with this huge pile of data? This is 80 gigabytes per genome. This is A's, T's, C's, and G's. How do I turn that from a whole big pile of digital information into something actionable that I can use for whatever my industry is? And so that's where our software as a service stuff comes in. We build platforms that allow people to interpret all of this information and apply it. And we've gone from having customers mostly based in research organizations who are saying, I want to look at these fruit flies. And I've got 4 of these fruit flies whose DNA I want to understand really well. And I'm going to figure this out over a process of 6 months, to people saying, I want to sequence a significant part of the population of the United Kingdom. And the demands those different customers have are pretty different. So what we need nowadays is not just to scale for this volume of data, but to be able to provide regulatory compliance to say, we're keeping this safe. You can't get much more personal information than the genetic makeup of a human being. And beyond that, what I'm going to talk about today is we have customers coming to us and saying, we want to use these products, but only if you'll build them here. We have these platforms running in AWS US East 1, and 3 years ago, that was the only place they ran. And then about 1.5 years ago, we said, actually, we really do have to do this everywhere that people want. How do we figure out how to build new installations of this big, complex application stack? And we have legacy things. We have a monolith that we built the better part of 10 years ago. We have microservices and services grown up around that, interacting with that. But we still have a significant investment of old code base and old technology that we can't just chuck out because we're a big company, we move, and we have people who've validated workflows against specific versions of these applications. So if you listened to Alexis's brilliant keynote this morning, you heard talk about GitOps and talk about how do we manage continuous delivery in a way where all of our configuration and all of our infrastructure is described in one code base. I'm going to talk about a lot of the same principles, but I'm going to focus in on something that he mentioned, which is if you're not using Kubernetes, you won't be able to do most of these things. And that's possibly true, but we do a whole lot of these things without using Kubernetes. So my hope is that if you sat and listened to that keynote and you went, well, this all sounds amazing, but it's miles and miles and miles away from where my organization is today, you'll be able to take some ideas from this talk and say, this will help us close that gap a bit. So let's dig in. I set off with binaries and with a configuration as code description in Ansible of the production environment we were running in the United States on AWS US East 1 at the time. And I took those things and I went, well, how hard could it be? How many of you run production environments or you're responsible for production environments, or when production breaks, someone will call you and ask you to help fix it? So a decent number. So some of you might relate to problems like this. Oh my God, we deployed this build, and it's crashing and burning, and we need to fix it right now, right this moment. And then you fix it, and that 6-hour-long conference call's finished, and you go home. And then do you put it back in your config as code base? Maybe, but at least a few times, maybe not. And this happens. You deploy your code base somewhere else, and you go, wow, something's broken here. And this time, that thing that's broken had broken and then been fixed 5 years ago in the United States, and the developer who fixed it at the time has left. So you're, flailing around and scrambling a little bit, and you haven't got the benefit of knowing exactly which one or two things changed with that last deployment because you're trying to apply a massive set of changes all at once. So making just one or two manual changes in your broadly config as code-driven process adds up over time. Over 2 weeks, 1 change is all right. Over 3 years, how many of those one-off changes have you made and have you forgotten about? Because I'm guessing if you run in the kind of not yet fully CI/CD-driven landscape that we operate in, that number adds up. Here's one case study of something we did. We use a tool called Hibernate to do database migrations. So the schema and the content of this MySQL database for the great big scary legacy monolith has gotten really big, and we went, well, it's okay because we have automated ways of managing it. And we do. We have a tool that people write C#, and then they put it in files, and then when you execute those files, it makes changes against the production database. Only, sometimes, those changes against the production database are really scary. And actually what we want to do is have a database admin step in and make those changes for us. We don't want to trust everything to this slightly daunting hands-off process that we have to back away from and that we can't back out of easily. So what we end up with is a set of database migrations designed for building development environments that don't match up to what's running in production. And when I sat down and I said, okay, let's take this on, great big monolith, let's run all these changes, I ended up with a database schema and a pile of database content with 10 million tiny little niggling differences from the production database on the other side of the world in the United States. So if you have this kind of issue, like if you have this kind of challenge where you know there's a big daunting pile of hard to track, hard to focus pieces missing from your configuration as code environment, what's the right thing to do? The right thing to do, in theory, is never create those changes. Have a working CI/CD pipeline and make sure that the only people touching your production environments are touching it through CI/CD tooling in a central location. It's driven by version control that's fully auditable. But we've talked a lot at this conference about how that works and about the fact that it's not an instant process. It's a cultural change. It's a process change. It takes trust. So I can't come to my database administrator team and go, you need to stop and only ever make changes through this tool you've never heard of. You're not allowed to run SQL statements against this database. And they're going to go, okay, do you want to manage the database then? And I'm going to go, oh my God, no. There are so many transactions a second over there. And I don't know what any of those things do. They need semicolons everywhere. Like, what is SQL? So it's a process of change. And while you're running to provide new business value, to provide these new environments, to fulfill these customers' needs, you need to deal with the fact you haven't actually been able to just flick a switch that says CI and then start doing CI and then a switch that says CD. And then, oh, no, like, now I deploy all these builds before my developers have even written them. So as a starting point, working in this potentially chaotic environment, what we found really helped is to pin down, how do I understand when my application is healthy? This will sound really obvious to a lot of people who live in happy lands where your applications are simple and greenfield. But at the start of this project, we didn't have any of this written down. Which apps need to talk to which other apps? Which apps need to talk to service endpoints for AWS? Which apps need to be able to talk to the internet? Which things can live behind a firewall and it's fine? Which ones need to be HA? Which ones contain state? Which ones talk to which backend data stores? These are all something that You might think everyone would know, but a junior developer in the development team hasn't necessarily ever seen production. It's a mythical land far away. And an operations person who only gets paid when something falls out of a load balancer doesn't necessarily understand what happens to make this healthy or unhealthy in a load balancer. So gathering requirements and then moving through with this beautiful configuration as code for your production environment over there that's maybe 70, 77% complete, means together you can build a starting point. Does my config as code copied out, all of the prefixes replaced, all of the IP addresses changed, all of the AWS service endpoints updated to be EU instead? What does that get me? A working environment? Yes? No? No, probably not. Go back, debug, change. I've got this service up and running, this one's still broken. Okay, what does that service that's broken need to talk to? You can iterate. Configuration as code, Ansible, Terraform, whatever tool you use, is pretty versatile, and it's pretty easy to say, I've made these 3 changes. And then when you've made these 3 changes and one more thing starts working, you understand things, you've tested those requirements. And you'll end up at the end of the day either with a complete config as code description that actually builds you production, or one that has 99.5% of the things, and then an itemized list, if you were writing down as you went along, of those missing pieces that are too scary to put in your version control, infrastructure as code, config as code-driven environment. So this in itself is a useful process, and it sounds obvious, but iterating through and then creating an accurate description and a trail of what is and isn't part necessary for building your working big complex environment is this place to start. When we started off on this, we had scheduled this project, we'd got a project manager on board, we made a Gantt chart, those are important, and the people involved in that project were 100% the operations infrastructure team. And, you know, why do you need anyone else? We have this code, we have these binaries, we just need to build infrastructure to run them on. If you're working in a cloud environment, your infrastructure is part of your code base to some extent. If you have a SDK that connects out to an AWS service endpoint, then it's making assumptions about the context and the environment it's running in. So look through your code base. Like, if you haven't specified a region to connect to, your SDKs are going to connect to US East 1. If you're talking to S3, then you need to be aware of, hey, which algorithm am I using to sign these requests? These ones are accepted here. These ones have been switched off in new AWS environments because security is important and they want to make you use the nice shiny algorithms, but they also don't want to make all of their old customers in the United States regions cry because their code suddenly stopped working because we switched off these algorithms that used to work. So code contains assumptions about the environment it's operating in. That sounds obvious, but it doesn't necessarily sound obvious to your senior leadership team. The other big piece that ops as a whole doesn't understand necessarily is what do you need for customers to be able to use your environment? So we built all of this infrastructure, got all of these services up and running and healthy, and then someone said, okay, but what about these workflow apps? Like, we've got like 30 of them and we don't have an easy way to move them from place to place. And it turned out that our customers, when they interact with our application, as anyone with domain knowledge of this app could have told me, they're launching apps. The app spins up an EC2 instance, pulls a Docker image onto it, and then it takes a config file with a whole bunch of URLs telling it which things to call back to when it's done its work, and uses those with some reference data to generate a bunch of useful analytics on genetic information. And we didn't have that S3 bucket with terabytes and terabytes of data in. And we didn't have all of these Docker images in a place this thing could reach. And we definitely didn't have an easy way of updating all of these JSON files to use these new URLs for the new places. So the lesson from this is that you need people to operate in a cross-functional way if you're going to get your application up and running early. And fixing that stuff after the fact, after we decided we couldn't resource it, meant that someone needed to do everything by hand. Next time, when we came out to build the third one of these environments, we said, man, I remember that. That was terrible. let's write a tool. And that took 2 weeks compared to the entire month it took someone to click through a UI and to upload all of these big files and to wait for them to time out and then try again. So that's building an environment. Building these environments is complex. It needs you to understand your environment pretty well if it's a big tangled mess, as so many of our software as a service products end up. And it can't depend on configuration as code any further than you've tested it. Like a backup, your config as code description of production is only as good as it is validated. So yes, you can probably run a deployment with that config as code thing. But actually, when you originally set it up, did you run it once? And then you realized you needed a new Route 53 zone, and then you made a zone, and then you put the zone ID in, and then you ran the code again, and it worked. And, you know, yes, it kind of worked. But in other ways, it kind of didn't work, did it? Because it didn't actually describe this environment in its entirety. So that's building things. Once you've built a new production environment, what you need to do is deploy to it and update it and keep it in sync. And this is like your goal when you have built one or more production environments is to be able to deploy code to them quickly to generate value for your business. And so we went, okay, well, great. We want people to always be available to take care of these environments. Going to build a new team in each time zone so they can do that. This sounds great. In reality, handing data off between time zones was something that no one had ever had to do in this arm of this organization. And trying to figure out how to do it left us stranded in a dark and mysterious landscape. And that was because at that time our deployment process looked like this on the right or left. I can't tell which orientation I'm in relative to you, respective to you. So we had walls of text, and I hope you can't read that wall of text because nothing in it matters. What matters is that our process for deploying was extremely context dependent based on this one release. This next release, we needed something else. And extremely environment specific. So I'd come and read one of these checklists in the UK morning that someone in California had written, and it would be about this US production environment. And I would say, I don't have that setting in my nice new EU, shiny EU world. What do I do? Do I skip this? Do I need to add that setting so I can configure it up? I had to make guesses on a regular basis, and making guesses about production is something that you typically want to avoid. So this is a process problem, right? What we did to solve this was I sat down with all the people managing these releases, and I said, we need to communicate better about this. And they said, okay, well, you've got this EU environment. We'll start making you EU checklists. And I said, can you make one checklist and then have little ticky boxes for US and EU? And then I'll look at it. And someone else will look at it, and they'll say, okay, this build's been deployed here, but not there. And then they'll write instructions for this that aren't specific to a specific environment, because there's an ulterior motive there. When it comes to deploying things in a structured fashion, what you want to do is not to have humans doing checklists. You want Git and configuration as code to be driving changes, because then you'll have an audit trail. And at the point where someone's writing a checklist that I can follow with no domain knowledge, that's following a predictable set of instructions, I don't need to be the person running that. Any kind of continuous delivery tool or anything that can execute a bash script in a safe and predictable manner can run that rather than me, a human, who wants to go home. So developing this process is the first step to facilitating a hands-off process. A handoff process to a completely hands-off process is for leading you along a path you want to go down. But let me dig a bit into the tools that we use to do this. So I mentioned Ansible and Jenkins in the title of this talk. And Ansible is the thing that drives most of our configuration as code, most of our automation work. We use Ansible in a slightly non-standard way, which is Ansible has roles, playbooks, and inventories. And what we do is write roles which contain almost the entirety of the logic that's needed to change live environments. So we'll have this role spins up EC2 instances and then untears them down. And the settings that get applied to those instances are entirely dependent of information in the inventory. So we keep configuration in the inventory, we keep logic, mechanisms for affecting change in roles, and we ensure that the roles will be idempotent. If you run a role once, it'll make one set of changes. If you run it twice, it'll make that one set of changes once, and then it will evaluate the state on the second run and say everything's as it needs to be. So then at that point, what do the playbooks do? They just orchestrate roles. They order the operation, the set of operations for a particular environment, which means that my role for managing load balancers can be used in this application over here, and then this one over there, and that one over there, without needing to know anything specific about the target environment. The stuff about the target environment's in the inventory. The stuff about orchestration and ordering is in a playbook, and the role itself doesn't need any context about the environment it's operating in. So what this does is give us a set of flexible building blocks that mean that we can reuse source code, we can write unit tests for them, we can ensure that teams will be able to treat these roles as a stable interface between the environment they want to build and the infrastructure they want to build it in. When we went from having, oh, my picture isn't appearing here. Okay, maybe you don't get this picture. It's a shame. It was a screenshot of an Atom text editor. Everyone loves those. So the way that we went from handling, I have this one inventory to this for this one environment, and this one for this pre-production environment, to I want to build multiple copies of the same environment and run them in different places, was by saying, I want to enforce consistency. That's the most important thing. Like, in order to do that in a complex environment where we had hundreds of Ansible hosts and thousands of lines of code containing all that detailed information about exactly how we want all of our infrastructure to look, was making a template that we could use to template out multiple copies of the same environment. So we have an inventory. The contents of the inventory are a list of hosts. The hosts aren't hosts in the sense of compute nodes that Ansible can SSH onto. They are environments. So each of those environments gets added into groups that describe the number of services that want to run in them. And the services contain a complete description of, hey, this needs to talk to that. It needs access to this security group that lets it talk to this particular data store. And we can add and remove different environments from that by just saying, like, hey, this is a member of this group. This is a child of this group. So at that point, we have hosts with CIDR ranges, region names, prefixes, names in them. And then we have groups that describe, like, that describe the actual contents of the services that should operate in them. So if I was starting this today, I'd likely use Terraform to accomplish lots of the same things because it's a much more concise way of describing the same set of resources for many reasons. And because the way we operate is by making EC2 instances from AMIs that contain applications pretty much in place already. So if you're looking at this and going, okay, that sounds like a useful thing in theory, how do I do it? The answer might be go and look at the current state of the tooling landscapes and choose the one that's right for you. But both of those things, deployment process and environment build infrastructure, our priorities there come down to how do we make it really easy to tell if these environments are consistent? Because that's what's important when you're running a really large number of hosts across a set of environments and deploying to them on a regular basis. You really need to have controls in place to evaluate, like, is this in the intended state? Is this in the same state as that? If I deploy the same build to two different places, I would like it to run in both of them without any hiccups and without me having to go to dig through for divergence. So that's building things. I'm going to talk a little bit about one of the things we got from building these Ansible roles, Ansible playbooks, Ansible inventories, and what that's patch management, which I mentioned we're a regulatory compliant ISO 27001 HIPAA kind of a shop. One of the big problems of getting those certifications for us was realizing that we didn't actually have a good mechanism for delivering software updates. And we looked at this XKCD comic. And how long, I'm guessing a bunch of people have seen this before because we all love to read XKCD, right? How long do you spend on a task before it's worth automating? For us, We patch once a week. We were spending an embarrassing number of hours doing that patching because we had our nice Ansible toolkit that could, once we'd built an AMI with Ansible, it had all the software updates, we scanned it with a security scanner thing, and then we deployed it. And the way we deployed it, because we weren't using auto-scaling groups at that point in time, was to take the Ansible playbook, limit it to run against only one host, tear a host down, spin a host up with the new AMI, wait for it to become healthy in the load balancer, and then go and tab up to get to the command line that we just run, and then change the number at the end of the host name, and then run it all again. And that's unskilled work. That's undifferentiated heavy lifting. And that's something you can do with Jenkins or any pipeline management tool. So we put together a process for this, which is build the AMI, validate the patch set, share the AMI out with the environments that need to run it, and then orchestrate this repeated task. So take a list of groups, build your environment on a EC2 worker instance because you don't actually want to lock up your Jenkins master server for as long as it takes to patch an arbitrary number of environments. That could be a pretty long time. So prepare this worker instance by pulling down all of the required code, and then take that user input there, so replace targets var, split it up, get a list of Ansible groups to replace the hosts within, and then run that exact same series of playbooks. Tear the host down, spin a new one up with a new image, wait for it to become healthy in a load balancer. And what this does is create a really nice, easy, at-a-glance way to audit that we've applied all of these changes. Because looping through in Groovy and creating a new stage for each one of these groups means the output looks like this. Did it work? Yeah, it's green, so it worked. If one of those boxes was red, I could click on it and I could get logs from this Ansible run and see which thing failed and why. So that goes from a process that took multiple days of a person's time every month, from a process that is click yes, and then come back 6 hours later and see, is it all done? Yeah, it's all done, awesome. So the reason that this works and was fairly trivial to implement is because we have those building blocks. We designed our Ansible roles so that they are idempotent. We can have a declarative definition of the infrastructure, and we took the time to build a declarative definition of this infrastructure. And then with those things in place, we could look around the landscape of what needed to be done and say, which of these things will scale up linearly as we add more environments? This takes n hours with this one environment in US production. If I build an environment in the EU, it takes 2n hours. If I build one in Spain or Australia or China or Singapore, how much is it going to add? And how much of that is actual hands-on time that a technical person needs to be sat there making decisions? So choosing those targets, automating them, and freeing up time means that we can continue on the CI/CD journey and start automating more important things. One of the things that makes that decision easy is that at this point, building a second environment in Europe, we could build it in exactly the same way as US East 1, with the exception of a couple of tiny little service level differences in AWS. So we set out to build the same thing in China, and we looked at China, and we immediately ran away, because AWS China diverges pretty significantly and demands different design patterns. I don't know if it's obvious why consistency is important in an environment where you're focusing on this kind of automation workload. Here's a couple of reasons. Inconsistencies between environments add complexity to your tooling. If you need to have a lot of if-else statements, if you need to have a lot of complex little side pieces of logic to handle that one edge case in that one place, then it makes it much harder to maintain that tooling. How do you know if you break anything without testing it on every single one of those edge cases? And it makes it much harder to learn how that tooling works. When you have a new hire who comes on board and they say, okay, so I want to spin up an AWS instance using your Ansible, and we say, all right, read these 400 lines of YAML, they're going to go, oh, could I just log in to the console and click those buttons, and then click those other buttons, and then have an EC2 instance? So that's an anti-pattern. You don't want to create tooling that's harder to use than the thing it automates. If you're going to have those edge cases and that complexity in there, you need to think carefully about how and why and where to incorporate them. And like most things in the technology industry, we often want to play with tools and extend them and make them complicated and deal with the interesting challenges for fun. And we should get to do those pretty much only when the business value of the work that gets delivered from those cool, interesting challenges renders it worthwhile. So here's what the challenges are when you wander up to AWS China and you sign up for an account, and then you realize you can't sign up for an account without filling in a large number of forms and handing over your business number and asking for an ICP recordal to be allowed to serve traffic on HTTP 480 or 443. AWS China is in a different top-level partition than the rest of global AWS. So if you can picture those 6-digit account numbers, if you're a person that works with AWS at all, then ARN, the first piece of that is normally AWS : In China, it's AWS-CN : And because of that, what that's telling you is that the authentication backend and the infrastructure backends are not compatible. So I want to share permission to an account in China to read objects from my S3 bucket. I wouldn't be able to do that by account name or user ID. I'd need to do it by an IP address or by some other form of authentication. The two things don't know what one another are doing. They've crossed like ships in the night. The other interesting thing that stands out when you first sign up to one of these is that when you create an account in AWS China, you get an administrative user provisioned for you within that account rather than the equivalent of AWS root, the root user. And that means someone else has that root account access and you don't. And then you look at some of the tools you might use to audit your account and you see like, oh, that anti-tampering things on that CloudTrail service that logs all API activity carried out in this account have all been switched off. And you take that information to your information security professionals because you're a responsible large organization. And they immediately go, hold it right there, folks. And then they go and talk to the marketing people and they say, oh, but there is a really good potential market there and we think adoption will be really great. And then you, as the technology professionals in the middle in charge of implementing big complex projects in the cloud, go, okay, what's my way forward? Do we need to make an exception here? The marketing people say we do. So what we did in this case is pick the line to draw that we would operate in AWS China, but we would not connect it with our corporate network. We had a DMVPN connection going into our management VPC and all the rest of global AWS. And in China, we said, no, we're going to make all these changes by AWS API. So we're never going to sit on a jump host in between the object store and the source code binaries that we run internally, so the source control tool we run internally on the one hand and our application environment on the other. We're going to sit in our own little bit of the internet and interact only by API with the service layer of AWS. So at that point, provisioning things, EC2 instances dynamically isn't an option. We need to send immutable AMIs into China. So we came up with a fun little workflow. We'd build these images in the United States. We would export them as RAW files or VHD files. We would copy them across the ocean through the Great Firewall, sometimes taking 12 to 20 hours to copy 13 gigabytes. And then we would register them, in the case of Windows, using the lovely, we want to steal customers from VMware VM import tooling. And we say, hey, we brought you this beautiful new AMI, please register it. And they'd say, yes, you can now launch EC2 instances from this. And we'd feel like we'd really cheated Mr. AWS man. We got around all of their tricks in order to continue to give them money on the other side of the ocean. So at that point, we have a mechanism to stand up the same structures we have elsewhere. And we get to use lots of the same tooling. We build those AMIs using the exact same set of roles, set of little modular building blocks that we use in the rest of the world. So this is a difficult project. Building things in AWS should not be the second place or even that you build something in the cloud. You should understand how the cloud operates in general and then say, AWS China, it's a different land. Let's carefully make exceptions for it and go into it with our eyes open because do you want Route 53? Do you want to create DNS records? If so, go somewhere else. or make little calls out from AWS China to a different AWS account somewhere else and manage 2 sets of credentials in order to do it. Yeah, the takeaway from this, on the whole, is that having building blocks that enable you to build consistent environments is really, really important, because reducing that time that it takes to add a new environment and to manage a new environment will be make or break for your ability to scale and your ability to operate in multiple regions. But if you take those building blocks and you think, how can I build flexibility into them? How can I make them modular enough that they can adapt to unexpected edge cases? You'll be able to do not just that consistent set of design patterns, but also to adapt those design patterns in the places where it really, really needs to happen. And that's China. I can talk in much more detail about any of those things if they sound interesting to you after this talk. So if you're about to set off on that journey, come and mention it to me. But overall, hopefully some of this is an interesting reflection on Alexis's stuff earlier. Keeping legacy environments running is pretty difficult in itself. Building new copies of them seems like a challenge you should try and avoid if you could possibly move to a microservices type method of delivering them. But if you can't, and if you need to deliver them right then and there and take that project done before the rest of it, then choose these DevOps principles. Make things work cross-functionally. Make sure you can validate and debug your applications quickly. Make sure you can automate away the work that isn't adding value to your team, to your process, to your ability to operate at scale and with speed. Be careful of divergence between environments and aim for consistency. And when you can, use templating mechanisms so that keeping things consistent across environments is not just quick and easy, but also actually no more work at all than just maintaining the one environment. So that's that. Thank you very much for coming.